Good morning, children. We are continuing with the chapter Structure of Atom. In the last class, we studied about atomic number, mass number, how the number of protons and electrons are related to the atomic number, and also how to find out the mass number, then also how to find out the number of neutrons when atomic number and mass number is given. So, I think all my students are clear about it. Today we are going to study about the electronic configuration of elements. So, how the electrons are arranged in these shells. So, when we studied the Bohr atom model, we studied that the numbering of shells as K, L, M and N shells. So, when we are drawing the Bohr atom model, you can see the nucleus at the center and the shells are arranged accordingly. The first shell is the K shell, second is the L shell and third is the N shell. So, we are going to find out how the electrons are revolving round. We all know that electrons are revolving round the nucleus. So, does each shell contain the same electrons? The K shell has the same electrons or whether the L shell has the same electrons? How the electrons are arranged? We are going to study about it. In the textbook, there is a table given here, isn't it? In this textbook, in this textbook, there is a table given here in which the electrons are arranged. When the first time you look at the table, you don't understand. In some there is only 2, in some there is only 8. Why like that? So, these shells, that is K, L, M and N shells, the arrangement of electrons or the maximum number of electrons that can be accommodated in each of these shells is different. Okay, as you know, K shell is the smallest shell, that is the first shell. Then as it is going to the next shell, that is the L shell, the maximum number of electrons that can be accommodated is different. So, how can you find out the maximum number of electrons that can be accommodated in each shell? The maximum number of electrons that can be accommodated in each shell. That is, here the maximum, to find out the maximum number of electrons that can be accommodated in each shell, there is a formula. Okay, not a big formula, a small formula, that is 2n square. So, if you remember that small formula, you can find out the number of electrons that can be accommodated in each shell. So, using that formula, we are going to find out the number of electrons in each shell. First, K shell. Formula is 2n square. Now, what is n? N is the number of the shell. Here, K is the first shell. So, 2 into 1 square is 2. That is, the maximum electrons that can be accommodated by the K shell is 2. Next is L shell. Formula is the same, 2n square, 2 into L is the second shell. So, n is equal to 2. 2 square. 2 square is 4. 4 into 2, 8. So, the maximum number of electrons that can be accommodated by the L shell is 8. Next, M. 2n square. You can also calculate with me. 3 square. 3 square is 9. 9 twos are 18. Then N shell. 2n square. 2 into 4 square. 4 square is 16. 16 twos are 32. So, the same way you can find out the maximum number of electrons accommodated in each shell. So, when you find out the number of electrons accommodated in each shell, what happens is that we will find it easy to draw the Bohr atom model according to the number of electrons. When we find out the number of electrons accommodated in each shell, it is easy for us to write the electronic configuration and also to draw the Bohr atom model. So, I will show you an example. So, first element is hydrogen. Atomic number of hydrogen is 1. Now, we can write K, L, M, N. Okay. Okay. Now, hydrogen. Atomic number is 1. So, K shell can accommodate 2 electrons. Maximum 2 electrons. So, we give the 1 electron to the K shell. Next is helium. Atomic number is 2. So, since helium is only having 2 protons or 2 electrons in its atomic number, or its atomic number is 2. That is, helium is having a maximum of 2 electrons. So, that 2 electrons we can give it to the K shell. Okay. Next is lithium. Atomic number 3. Okay. So, 3. So, first shell, it is a K shell, we can give the maximum capacity. That is 2 electrons. As you know, K shell can only accommodate 2 electrons. So, 2 electrons we have given to the K shell. What is the remaining? 3 minus 2? 1. So, that 1 electron we will be giving to the L shell. Okay. Now, lithium. Next, beryllium. Atomic number 4. Okay. Here, same. K shell, 2 electrons. 4 minus 2, 2. That 2 electrons will go to the L shell. Next, boron. 5. So, keep in mind that L can accommodate maximum of 8 electrons. That you have to keep in mind when you are writing the electronic configuration. 5. Now, here, maximum 2 electrons in the K shell. What about L shell? 5 minus 2. How much? 3. Then, carbon. 6. K shell is having 2 electrons. Remaining 4 electrons goes to the L shell. Now, oxygen. No, not oxygen. Nitrogen. Atomic number 7. Maximum 2 electrons in the K shell and 5 electrons in the L shell. Okay. So, in this way you can accommodate, or you can accommodate the electrons in the K, L, M and N shell. The further atomic numbers of elements will also be shown here. So, in the last table, we accommodated, or we gave the distributed the electrons to the K and the L shell. Now we are continuing with it. Now here it is oxygen. Now I think it is easy for you to fill, isn't it? For oxygen, atomic number is 8. So we will be giving the 2 electrons to the K shell. Why 2 electrons to the K shell? Maximum number of electrons that can be accommodated in K shell is 2. So only 2 electrons to the K shell. Remaining 8 minus 2, 6. Now next is fluorine. Atomic number 9. Here K shell is having 2. 9 minus 2, 7. Next, neon. Atomic number 10. Maximum number of electrons in K shell is 2. 10 minus 2, 8. So from this what you can understand? The maximum number of electrons in L shell has finished. See, here K is having a maximum of 2 and L shell is having a maximum of 8 electrons. So already we have completed the maximum capacity of 8 electrons. Now, if you come to sodium, which is having an atomic number of 2, how will we do? See, 2 electrons to K shell, 8 electrons to L shell, 8 plus 2, 10. 10 minus 11 minus 10, how much? 1. So 1 electron to the M shell. So after filling the maximum number of electrons in the L shell, the next electron can be given to the N shell. Okay. Now magnesium, similarly 2 in the K shell, 8 in the L shell. 8 plus 2, 10. 12 minus 10, 2. Next, aluminium. atomic number 13. 2 electrons in the K shell, 8 electrons in the L shell. Here already 10. 13 minus 10, 3. Silicon, atomic number 14. 2 electrons in the K shell, 8 electrons in the L shell, and 8 plus 2, 10. 14 minus 10, 4. So in this way you can fill the electrons in the shells. Okay. Now here we have distributed the electrons according to the shells K, L, M, etc. Now using this, how we can draw the Bohr atom model of some elements. Okay, we are going to draw the Bohr atom model of some elements. First, lithium, a small element. Atomic number is 3. Now K and L shell. K is having a maximum of 2 electrons. Rest of the 1 electron will be going to the L shell. Now we are going to draw the Bohr atom model. So when you are drawing the Bohr atom model, first you have to write nucleus here. Okay. So how many shells are there? 2 shells are there. So what will we draw? First we will draw the K shell. Next you will draw the L shell. Now after drawing this, we are going to distribute the electrons here. How many number of electrons are there in the K shell? 2 electrons. So 1 electron here, 1 electron here. So 2 electrons are distributed in the K shell. Now how many number of electrons are in the L shell? Only 1 electron. So 2 electrons in the K shell and 1 electron in the L shell. Oh. Now what about nitrogen? Atomic number 7, isn't it? Here maximum number of electrons in the K shell is 2. And what about the L shell? 7 minus 2, we have 5, isn't it? 5 electrons. Now we are going to draw the Bohr atom model. Now 2 electrons are there already there in the K shell. Okay, 2 electrons are already there in the K shell. How many electrons are there in the L shell? 5. 1, 2, 3, 4 and 5. So see, 2 electrons in the K shell, 1, 2, 3, 4, 5 electrons in the L shell. Now we are going to draw a much higher element. Let it be magnesium. 12. Atomic number is 12. Here maximum number of electrons in the K shell is 2, L shell 8, M shell 8 plus 2, 10. 2 more electrons left. So 2. Now we are going to draw the Bohr atom model. How many number of, first you have to think how many number of shells are there. So before drawing the shells, you will write nucleus in the center. You have to always represent nucleus in the center. Now K shell, L shell, M shell. Okay, when you draw in your notebook, draw it neatly. You can use your compass also, so it will be very neat. Okay, so now first we have drawn the shells, that is K, L and M shells. Now we are going to distribute the electrons. 1, 2. Okay, 2 is done. Now 8 electrons in the L shell. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons in the L shell. Done. Now how many electrons in the M shell? 2. 1, 2. Okay. So in this way you can draw the Bohr atom model of any element if you correctly know how to distribute the number of electrons in the shells. Okay, it will be very easy for you. Now we are going to study one more thing. That is, if this atom model is given, what all things can we find out from that? Okay. So here the atomic number of aluminium is given here 13 and mass number is 27. Bohr atom model is given. From that we can identify the atomic number, mass number, number of protons, number of electrons, number of neutrons and its electronic configuration. So as it is given, the symbol is given here, it is easy to find out the atomic number and mass number, isn't it? Atomic number is 13. Mass number is 27. Then what you can find? Number of neutrons you can find out, because mass number minus atomic number is the number of neutrons. So number of neutrons is 40. Now, what is atomic number? The total number of protons or total number of electrons in an atom, isn't it? So, protons, 13. Now, you can find out the number of electrons. So, you can find out from the atomic number also, but from the Bohr atom model, how can you find out the number of electrons? Just count the number of electrons distributed here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. So, the number of electrons is 13. So, since the number of electrons is 13 here, atomic number same, protons same. Now, you can write the electronic configuration KLM. Maximum number of electrons 2. L 1, 2, 3, 4, 5, 6, 7, 8. L shell 8. M shell 1, 2, 3. 3. Okay. So, if the Bohr atom model is given, it is easy for us to find out the number of protons, electrons, its atomic number. Okay. So, here you can see 3 names: protium, deuterium and tritium. Okay. And you can see some atom models represented here. One is having 1 proton, no neutrons. The other one proton and 1 neutron. Third one, 1 proton and 2 neutrons. 1 electron each. Okay. This figure is given in your textbook. Now we are going to find out the number of protons, number of electrons, number of neutrons, atomic number and mass number. Now, first, number of protons. In protium, how many protons are there? 1. In deuterium, 1 proton. In tritium, 1 proton. Number of electrons, 1, 1, 1 each. So, number of electrons 1. Now, number of neutrons. In protium, there are no neutrons. 0. In deuterium, 1 neutron. In tritium, 2 neutrons. Okay. So, in this protium, deuterium and tritium, all the protons, the number of protons are same in all these elements. Number of electrons is also same in all these elements. But the number of neutron is keeping on increasing. Okay. Now we can find out the atomic number. So atomic number means the total number of protons or electrons in an atom. So since the number of proton in protium is 1, atomic number will be 1. In deuterium also the number of proton is 1. So the atomic number will be 1. In tritium also the number of proton is 1. So here also it is 1. Now what about the mass number? What did you study about mass number? Mass number is a total number of protons and neutrons, isn't it? Okay. So mass number 1 plus 0. 1. Next one, deuterium 1 plus 1. This one plus the number of neutrons. It is 2. In tritium, the number of proton is 1, number of neutron is 2. So, the mass number is 3. Okay. Now we are going to write the symbol of these elements. Okay. So, first, now, since the number of protons and number of electrons is 1, What will be that element having only one electron or one proton? Yes, hydrogen. Okay. In all the elements, the number of proton is 1. So we can represent it as hydrogen. Now we will represent the atomic number. What is the atomic number in all the cases? Only 1. 1, 1, 1. Now we are going to write the mass number. In protium, the mass number is 1. So no problem. In deuterium, the mass number is 2. And tritium, the mass number is 3. So, after I have written the symbol of these elements or the symbol of these elements, what do you understand from this? From this formula of these elements, protium, deuterium and tritium. The atomic number, same. Okay. But mass number is different. So why the mass number has become different? Because number of neutrons was increasing. Number of neutrons was increasing. That is why the mass number became different. Okay. So those elements which are having the same atomic number but different mass number, we call them by the name isotopes. Okay, those elements which are having the same atomic number but different mass number, they are having the name isotopes. Now, there's only hydrogen. Don't think that only hydrogen is having these isotopes. There is another similar element known as carbon. Okay, carbon. Now, carbon is having the atomic number 6. Okay, and the mass number is different. See, carbon 12, this is the normal carbon atom. Then the other isotopes, carbon 16, carbon 13 and carbon 14. Okay, the other isotopes of carbon are carbon 13 and carbon 14. Now, is there any importance regarding these isotopes? Yes. Isotopes do have any importance in medical field, in industries, in nuclear reactors, etc. Now this element, this carbon 14 is an element which is used to study about the age of fossils. These are some of the uses of these isotopes. Deuterium is an isotope of hydrogen which is used in atomic reactors. Then phosphorus 31 is another isotope. It is an isotope of phosphorus. It is used as a tracer for identifying nutrient exchange in plants. So you know that NPK are the fertilizers. NPK are very essential nutrients in plants. So the phosphorus 31 is an isotope which is used to identify whether nutrient exchange is taking place in plants. Now iodine 131 and cobalt 60. Okay, these are the names of some isotopes. Please study that. It's very important. They are used in diagnosing some diseases like cancer and tumor and also in treating them. And last one is uranium 235 which is used as a fuel in reactors. Okay, so these are some of the important uses of isotopes.